probability sampling, you need to be lucky to get a good sample, okay? But typical good sample come from what? Probability sample. What is a probability sample? This is a definition. A probability sample is a sample chosen by chance. To use a probability sample, we must know which sample are possible and the probability choosing each of these samples, okay? Some types of probability samples are simple random sample. This is the most important one, okay? This is a theoretic foundation for all sampling theory. It begins with what? Simple random sample. And let me explain what's a simple random sample. It's very easy concept. Simple random sampling means drawing at random without replacement, okay? Fill the blanks. Without replacement. Okay, without replacement. And simple random sample can be conducted with replacement instead. This is less common and would normally be described more fully as simple random sampling with replacement, okay? Sampling done without replacement is no longer what? Is no longer independent. This is very important concept, okay? So let me explain. Look at this box here, okay? Let me draw you in a separate piece of paper so you may be what? Follow patterns, okay? Now, let me use the scratch paper here, okay? First, I draw a box. Inside the box, this is an example. Example for simple random sample. Say there are 4 balls in the box. Ball number 1, ball number 2, ball number 3, and ball number 4. And N, capital N, this is population size. And we make what? We make 3 draws from the box. So what's the population size? Population size is 4. What's the sample size? Sample size is 3. It's 3, okay? And simple random sample, as I mentioned earlier, is what? Without replacement, okay? Without replacement. Is that better? Without replacement, okay? So what is a possible sample space? If you read probability theory, there are 4 different possible samples. I can select ball number 1, ball number 2, ball number 3. Or I select ball number 1, ball number 2, ball number 4. Or I select ball number 1, ball number 3, ball number 4. Or I select ball number 2, ball number 3, ball number 4. Okay? So in this case, how likely I select what? Ball number 1, 2, 3. I will select this one with probability equal to what? 25% chance. How about 1, 2, 4? Same thing, with probability equal to 1 over 4. 1, 3, 4 with probability 1 over 4. 2, 3, 4 with probability what? 1 over 4. Are you with me? So in this case, we have 4 simple random samples of what? Of size 3. Okay? We have 4 simple random samples of size 3. Are you with me? We have 4 simple random samples of size 3. Each one we will get it with what? With 25% chance. They are equally likely. Okay? Moreover, how likely we're going to include ball number 1 in our sample? Look at here. The chance we're going to include ball number 1 in our sample. 1, 2, 3, 3 out of 4. So that chance is 3/4. Okay? How likely you're going to select ball number 2? It's also 3/4. Select ball number 3. 1, 2, 3, 3 out of 4. Ball number 4 is also what? Is also 1, 2, 3, 4. Am I correct? 3 out of 4. So chance each individual will be selected or will be included in the sample is 3/4. And how come this 3/4? How can we get 3/4? It's because n over what? Capital N. It's a ratio between sample size and the population size. So let's repeat the key point again. How we define simple random sample? In a simple random sample, sample of the same size, in our example, size is 3. They are all equally likely to be selected, each one with chance what? 25%. And not just that, each individual in population, the chance they will be included, okay? Each individual is included in the sample, also the same. Ball number 1, ball number 2, ball number 3, ball number 4 will be included in the sample. They are all equal to 3/4. Where 3/4 come from? Come from this ratio. It's the sample size divided by population size. Okay, that's it.